Great, thanks for the introduction. And thanks everybody for coming here. So nice that you asked this question because I was going to ask them in the first place, so we optimized a little bit for time. Maybe one more question. How many of you actually built already something with VisionOS? Okay. Great, so as you've seen outside, this session is going to be about best VisionOS practices for beginners. If you can learn at least one new thing today, I think that would be fantastic. So just a brief introduction about us. My name is Enrique. I'm serving as the Android chapter lead at Code and Theory, a company based out of New York. I'm a Google developer expert for Android and Kotlin. This is my Twitter handle. And my colleague?
Yeah, I'm Supreet Singh. I've led a lot of mobile engineering teams. I've also been an iOS architect and now doing a lot of VisionOS architect work. Find me on LinkedIn, open to new opportunities. Let me know.
Right, he's the real expert on VisionOS. Nice, so let's talk about VisionOS. As you know, well, it's the Apple spatial computing platform. It has been officially released on February 2nd, 2024, even if there was a version that was announced earlier and you could download and practice on your Xcode. Somebody said that this is like having an iPad on your face plus some magical spatial framework. Was that a random developer? Was that you? Was that me?
Was that me? Yeah.
And well, currently the only device that supports VisionOS is the Apple Vision Pro. However, there are some cheaper options likely coming. There has been some rumors, if you have been following this, so Apple might have realized that, well, I think it's like $4,000 including taxes and everything. That might not be your average user, and it's probably, at some point there will be a version that maybe trims a little bit on hardware or anything. And there are three main ways to build applications for VisionOS. We can use the native VisionOS framework. We can use Unity, which all of you might know. And of course, we can also use web to develop applications. Each of them has some set of advantages and disadvantages. Well, if we use the native VisionOS, we're using the SDK that Apple provides us to develop applications. It's very optimized for the hardware and let us create applications that are a little bit more performant than if we're using Unity on web. It's similar to when you're developing applications for mobile phones and you use either the native Android SDK or the native iOS SDK versus using Flutter or React Native. Some of those frameworks could be a little bit more of general purpose, and some other ones are more, well, specialized in the specific hardware. Here we have access to Metal, is the 3D graphic and computer shader API from Apple, and you have full integration with the Apple ecosystem. This means that you can benefit from libraries that already exist for Apple. If you are, we can be talking about networking libraries or logging libraries or whatever libraries that are already available. We can create custom user interfaces using the VisionOS SDK. And of course, we can also benefit from using the Apple developer tools. We are going to be developing applications using Xcode, and this means that we can use the debugger from Xcode, the profiler tools, all these sort of things. Now, Unity, it's, well, this graphics SDK to develop applications, video games, etc. We can also use it for developing VisionOS applications. Some advantages with Unity is that it is cross-platform. So we can, what we're developing on Unity can be exported later for Android or iPhone and of course, VisionOS. They provide, they specialize in, well, 3D tooling. So there are some specialized tools in spatial computing or advanced 3D. And one interesting advantage is that they have a very rich asset store. So if we need to acquire things like textures or 3D models or sounds or effects, we can just go to the store and get it, get the license, and it's very easy to start up and running and developing your apps. And we also have access to real-time rendering and physics in a much more specialized way. And of course, last but not least, we have the option of developing applications using web, a web framework. The advantages are that, well, there is a widespread accessibility. It's much easier to manage deployment and updates. As you know, if you are developing a web app, every user has the latest version of your app. You don't need to worry too much about getting them deployed and making sure that every user is installing them, as it happens on mobile applications, right? So if you have a number of users, they might have like 1, 2, 3, n number of versions, and this can lead to some inconsistencies and problems, because you need to make sure sometimes that, hey, update so you can have the latest features, or make usage of the latest things I have on the SDK. That doesn't happen with web. We would be using WebXR and WebGL to develop our 3D components, and same thing as with the native VisionOS SDK. We can integrate with existing web APIs, and we can benefit, of course, of having a responsive and adaptive design. Now, how to move from mobile to spatial? This is probably going to be a very common use case for VisionOS developers, because you might have been developing already some applications for iPhone that you want to port into VisionOS. Well, this is without being straightforward. Nothing is straightforward in life. Apple provides a very easy way to do this. We will be building using the Swift UI components that we already use for our mobile apps. We can reuse any iOS or iPad OS framework, so no need of reinventing the wheel if the wheel has already been invented at some point. And we need to understand the best practices in order to develop effectively our VisionOS application. My colleague Supreet will start introducing some of them.
Yeah, so we had a bunch of mobile devs on our team try VisionOS, and I think they found all the common pitfalls of being a mobile dev, a 2D dev, trying to get into the spatial world. So we took all their mistakes and tried to make them into 5 best practices for you here. So the first one is going into 3D. They really wanted to use 3D models, like put 3D models everywhere. And in actually testing the experience, we found out that it's okay to have 2D as well. So an example is a simple one here of like if you had like a soda drinking experience, like it's okay to have a 2D start page where it just tells you what it is and has a simple button that you can use to get into it. What they were doing instead was actually something like more like this, where you kind of saw a 3D can and you had no idea where you were, what you were doing, what was the next step. And Apple really does encourage this, right? They have the windows, the volumes, and they're trying to encourage people to really think about the experience and not just throw you deep into 3D immediately. Try to build up to that. So the second one is the fully immersive, and you'll see this in the way Apple is pitching the framework, is very special. Like really throwing someone into a fully immersive world really needs to provide a lot of value, because by default, you're in that shared space. You have multiple apps. You need to be able to jump through them. And you should think about fully immersive as something that's even more valuable than having your top 5 apps side by side. Like it should be really special. And another thing we learned too is it can be a little jarring to go straight into fully immersive. And a lot of times people try to get out of fully immersive because they don't want to be there, honestly. So a good practice is to kind of start with the windows, maybe go into 3D volumes, and get people comfortable with your experience as a whole before you go into fully immersive. Another thing we noticed was a lot of these developers didn't have access to the actual hardware, right, for a while. And so they were doing a lot of work in the simulator, and there's a lot of things that you can do, and you can go very far in the simulator. But some of the things we found was, we're up here in the slide, and one of them is just the scale of objects. Like you can obviously look at the measurements, look at the scale of your 3D objects, but on device it's very different, right? You don't really know exactly how close you're standing to it, how it's scaling as you walk towards it and away from it. Also, you can't really do hand tracking in the simulator, so if you have anything around that, you need the device. And even just the sense of field of view is hard to gauge, because obviously if you have multiple windows in your application, you want to place them so people can see them. You don't want it to be behind them and they don't know what's going on. Another one too that's hard to judge is if you do have animations and movement in the simulator, it might look fine because it might be it's 2D and it's pretty wide. But when you're wearing the device, like something that you thought was a very small movement could look very big and very jarring, and you don't really get that feeling until you actually try it on the device. And also it kind of goes hand in hand with you don't want to encourage people to move to a spot which might actually be really far when they have the headset on. Another thing we learned too is developers really wanted to add everything at once, like all the animations, all the sound effects, particle effects, all in the beginning. And that also is a little jarring for people because you're not really expecting it. So we kind of encourage them to sprinkle that in. We call it kind of sprinkling emotion into the experience. Like start with 2D, start simple. It's actually a lot more powerful to have something simple and then do an animation than just have like 5 animations all at once. And then also that goes, other things you can do, obviously the sound effects, the particle effects. So here's an example of going back to that can example where, as you open the can, you can have a sound effect of actually opening the can. And you also did stuff, where you like whenever you touch an object, it could like make a crinkling noise and things like that, which make it more engaging. The other one, particle effects, are actually very easy to create with Reality Composer Pro. So if you have any fear of particle effects, you should definitely open up Apple's Swift Splash is a great demo code base. If you get that, you can open it up. I mean, one of the things they have in there are these fireworks. And you can actually go into Reality Composer Pro, completely see how this is built, look at all the assets they used, all the settings they used. And it'll look something like this, where you can actually see all the assets at the bottom. Like here, we're looking at the actual particles for the fireworks. And on the right, you can adjust everything. You can change the size, you can change the emitter, the particle size. And it makes it a lot less scary to get into it. But it's very easy to add these effects with Reality Composer Pro. And it's probably the best use of this tool, is to add this stuff. Okay, now I'll send it back to Enrique for interaction design.
Yeah, so let's talk a little bit about interaction design and UX guidelines. So simple is usually better. And well, when it comes to interaction design, we should be following the Apple UX guidelines, and let's gonna see a few of them. There are actually 2 types of gestures being supported. One of them is the direct gestures. You can see here the type of gestures that are supported. We can touch to select or activate an object. We can touch and hold to open the contextual menu, where we get further options for a specific screen. We can touch and drag to move objects through different locations. We can double touch to preview objects. We can swipe to reveal new actions and controls. And then we can pinch and drag together with 2 hands. Now, we also have the indirect gestures, which I think are generally not overseen and underused, but they can help us in combination with the direct gestures to provide the user with more options for interaction. For instance, as we are moving our eyes and head, we would be highlighting certain components. And when the component has been highlighted, we could use, for example, a pinch to select this object. We can see an example here. You see that the eyes are moving, the heart is being highlighted, and then we can pinch to get it selected. So combining indirect gestures with direct gestures is going to open a universe of possibilities for our users. Some other guidelines. We should favor transparency over solid colors. And yeah, as you can see in this example, on the left, there is no transparency. We just have a very opaque object, whereas on the right, we have the right approach, which is we have the same object, but we are applying a certain alpha to make it transparent and still be aware of our surroundings, because that's the thing. If we have like opaque blocks and panels, we are not aware of the surrounding around us, and that's probably going to be detrimental for the user experience. We should avoid placing content either too far up or too far down. The reason is obvious. We're having a device that has a significant weight on our heads, and imagine if you need constantly to be pushing your head up or down or moving left or right. It's not going to be a pleasant experience. Now, by default, we should be using white as the text color. This maximizes legibility and makes a much cleaner interface. This is, for example, the Spotify application. And I believe if you are using the UI label, the standard text component for VisionOS is white by default. So you should not be experimenting too much with, new design systems and font colors and everything, because Apple is very vocal on this. Just use white unless there is a very specific need, which probably doesn't happen for most of the apps. Now, we should be using color only in background layers. If you must use color, do it in the background. You can see here on this screen that on the left panel, we have a button for dismissing the panel and another one for eventually joining a call, right? We have, on the left one, we are not using the background color, on the right one we are. And it's obvious which one is much more visible. In the left example, the text is sort of mimicking with the background as well, and well, this is not a pleasant development experience. Another guideline, we should not be stacking light material. This is because light materials can blend, and it can make it difficult to see all the different layers that we have. On the left example, on the first example of all of them, there has been a few light materials that have been stacked, and it's harder to see and to use than the other two examples, where the components are not stacked and you can see them independently. Probably connected with the fact that the contents and the panel should not go too much into another directions, we should tend to center the content. So the user is sitting in a relaxed position and is directly accessing the panels without having to move the head too much. Some UX more guidelines. There is something called the rule of the 60 points. Interactive elements in VisionOS apps and games must have a target area of at least 60 points. This means that the entire interactive element, including the padding, must be at least 60 points wide and 60 points high. Don't do it smaller because it's going to be very hard to interact with it, and using also the indirect gesture to select it and then eventually pinch it or do any interaction with it. Every single element should clearly indicate the state of or we should clearly indicate the state of the elements to the user. This includes interactive, inactive, or selected states. We can accompany them, for example, with a hover effect when the user is focusing on them. So the element is having this sort of interaction when this glance effect when the user is hovering over them. We should not be using more than 6 items on a tab bar. This is probably a common mistake. We just start adding more elements, and at some point we have 8, 10, whatever, and this keeps growing and being increased. If we have the need of having more elements than 6, what we should do is to rethink our aggregation approach. So instead of having, let's say, 10 elements, we probably can move it down to 5 and see what's the hierarchy that we want to have. Then maybe we want to have a group. After we click on one of the elements on the tab bar, another menu opens with different options. But it should not be larger than what you see here on the screen. And yeah, back to you with ornaments.
Yeah, so this is just expanding on what Enrique is talking about. Even when you have like a lot of content on the screen, Apple has ornaments to get controls off the main content area. So it's another tool just to use to keep a simple user experience, so you don't have people overwhelmed with too much going on at once. And to summarize, follow the UX guidelines. Apple has a lot of great material on the website. Choose the tech stack very wisely. The beginning of the talk, the 3 different options. They have very clear pros and cons. I think it's pretty easy to figure out what you need once you kind of go through the process. Like we talked about, simple is usually better across the board, from UX design to the overall experience, to 3D, to animations. And everything that you do, make sure it's adding value to the experience. So every time you add something, think about the value that the user is going to get. And if you can, try to get it, to have your experience tested on device with actual people, either at your company or your customers, as soon as you can. And yeah, and then we have some sources here of the stuff we used. Any questions?
By the way, this is a QR code. If you want to leave us any feedback, things you like, things you didn't like, we would highly appreciate it. So we can use it to improve and see how, what people are asking for. And maybe here on the links, there is the Swift Splash demo, which I think is very interesting, right?
Yeah, it was a good one.
Well, I think it's a very complete app. You can see some of the best practices. You can see also some impacts, particles, right? You can see the fluids with water. So it's a very complete all-in-all app.
Yeah, it's a lot of code.
So yeah, that's it. You've been a fantastic public. If you have any questions and we happen to know the answer to those questions, we would be more than happy to help you. And just as a disclaimer, AI was used only for text correction. So I think that's probably an important disclaimer in 2024.
A few minutes for questions, and I'll run the mic to you so that we can capture the audio on the recording.
Yes, hi. So say, great presentation. Say I had a question about, I didn't want to use Unity and I wanted to have an application that compiled to Vision Pro and like Quest. What would you recommend to like maximize sharing code, especially given the fact that building natively, they aren't intuitively designed to do something like that?
You said VisionOS and which other platform?
VisionOS and like Quest.
Yeah. Well, Unity is a candidate, right? Since it's multi-platform, you can target different platforms. And that's sort of a Pandora box, because then we could start talking about, I don't know, like Swift multi-platform, for example, Kotlin multi-platform generating an iOS framework that later gets imported. It's, I think, like all the answers in tech, it depends a little bit on the, your team expertise, the SDKs that you're already using, stack. I would say probably a good start is Unity, because it's, the multi-platform framework in XR and augmented reality. And then based on other things, you could start including, maybe Swift multi-platform, Kotlin web, but definitely I would consider Unity at first. You have any?
Yeah, I mean, I think you could just, if you wanted to keep it native on the front end, you could try to extract as much logic into services or backend modules, try to reuse as much 3D assets as you can. That's another option.
I think probably the bottleneck in performance is going to come mostly to graphics. Like if you have a multi-platform framework that is taking care of the networking, that's probably going to have an acceptable diminished performance, but graphs is something that you would like to get as close to the hardware as possible to avoid having things like, I don't know, like laggy animations or laggy particles or those things.
One more question over here.
Thank you. Hyla Lacefield with Kenyatta Community College in Redwood City. We're halfway between San Francisco and San Jose. We've been using Unity for development, but I came here to explore VisionOS development at our college, but it is really challenging to get to the right people at Apple to even grant you the permission to do that. Do you have any advice as to how to find the correct people? Because they're just trying to sell us more devices. And we're like, we have the devices, we need to have the access to the developer when it's a group, not an individual. Does that make sense?
Mm-hmm. Well, my experience, I think Apple lacks in terms of developer relations. Google, for example, is very well known for having an entire team of dev Rails that you can write on Twitter or, I don't know, Mastodon. They're very accessible. When I personally had issues with Apple, I went to LinkedIn, I searched for developer advocate Apple, and you end up finding some. It's not a huge community. Apple is also not known for having community events like the DevFest at Google and all those things. But that would be my first attempt, trying to find a local dev Rail in your area. And I mean, their job is actually to support other developers. So I would expect them to be open to discuss any matter with you.
We have another minute or two if there are any other questions. All right. Oh, one more question? All right, let's do it.
Hey, thanks for everything. Do you have a recommendation on which SDK or something to use for WebXR? A-Frame, Babylon, because I know two of them. You know, something that goes along well with the Vision Pro.
Yeah, I think you'd be fine with either one. I think just whichever architecture you prefer.
Okay.
Yeah.
Are those two just the best you could use for?
Yeah, they're still the best things to use, for sure.
Okay, awesome. Thank you.
And they're probably always going to support Vision Pro.
Okay.
So.
Thank you.
All right, well, let's give Enrique and Supreet another round of applause.